Hello everyone. In the previous session we have discussed a few basic integral problems. Now we are seeing the integration by different methods. Okay, integration by methods. So here this is for the indefinite integrals. So there are total 3 methods are there. First one is the integration by substitution method. This is the first one, substitution method. Okay, and second one is integration by partial fraction. And third one is integration by parts. These are the 3 different methods. Okay, these are the 3 different methods. First we will see what is the substitution method. First I will start with the substitution method. Substitution method. Simple this is. To use this method you should be good in differentiation as well as integration. I mean in this substitution method we have to use both integration and differentiation. For example, let me consider one example. See, integration of sine mx into dx. You know the integration of a sine function, right? Integration of sine will be equal to minus cos x. So integration of this directly I can write this is equal to minus, right? Cos, in the place of x here we have mx. So minus cos mx. But here the variable is multiplied with constant here. So you need to divide by here plus c. Right? So this is by the direct method. But for few problems direct method is not possible. At that time we need to use the substitution method. Okay? For same problem we will use substitution method. Let me consider this integration of, that is I is equal to integral of sine mx into dx. The name only says substitution method. So you have to give the substitution for some independent variable. Okay. Here if I consider this is the independent variable, let us give the substitution for that. That is the first step. Let I consider mx is equal to t. Okay. For this problem direct method is possible. But for few problems direct method is not possible. At that moment you have to use the substitution method. So let mx is equal to t. After giving the substitution, you need to differentiate. Okay, after giving the substitution, you need to differentiate, and by differentiating, you have to substitute the value for dx. Is it clear? First, you have to give the substitution. So I have given mx is equal to t. Now differentiate. Okay, differentiate with respect to t. Here we are not integrating. Remember, you are differentiating the function. So if I differentiate, m is constant as it is, derivative of x with respect to t, that will be equal to dx by dt, right? And derivative of t with respect to t will be equal to 1. By using this what I can write? M into dx is equal to dt. But I need to give the substitution for dx, right? We are giving the substitution for dx. So by this what I can write? Dx is equal to dt divided by m. Right? Now integral I can be written as integration of sine mx is, we have given the substitution as t, substitute sine t. Next what is dx? Dx will be dt by m. Is it clear? Dt divided by m. Now here 1 by m is constant. So I can take out 1 by m into integration of sin t. Integration of sin t will be equal to minus cos t. So this is equal to minus cos t plus c. Right? So this one can be written as 1 by m into minus cos. We have given the substitution of t as mx minus cos mx plus c. Is it clear? Both are same. See this one? Minus cos mx divided by m plus c. So this is by using the substitution method. Is it clear? This is a simple problem. And few problems you have to use this method. First, what you have to give? You have to give substitution for some independent variable. After that, you have to differentiate that function. Then you need to substitute each and everything. Then finally you have to integrate the given function. Okay, we'll see few more problems. Now look at this problem. Integration of 2x sine of x square plus 1 into dx. So you need to find the integral of a given function. Direct method is not possible. Right here sine of x square plus 1 is there, and again here 2x is there. So directly we cannot integrate the given function. So we need to use the substitution method. Which substitution we can give? Can we give 2x? See here, if I give the substitution as 2x, after the differentiation I will not get this one. Right? So we can't give the substitution as this one. We have to give the substitution as x square plus 1. See, if you give the substitution as x square plus 1, after the differentiation, derivative of x square will be 2x. Here we have that, right? So that we can give the substitution. I hope you are getting this one. So we have to give the substitution for independent variable. So this one I will give. Listen carefully. So let first step x square plus 1 is equal to some t. You can give anything t, u, v, something. Okay. X square plus 1 is equal to t. Next step we need to differentiate, right? Differentiate the function with respect to t. Whatever the substitution you had given same you have to differentiate. Okay. Derivative of x square will be 2x, but you are differentiating with respect to t. So derivative of x with respect to t will be dx by dt is equal to derivative of t will be 1. So I can write 2x into dx is equal to dt. So clear? We got 2x into dx is equal to dt. So I can say this as I is equal to, see here, integration of sine, I'll rearrange that, sine of x square plus 1 into 2x dx can be written as, this is equal to integration of sine of x square plus 1. Substitution is t, right? Sine t into 2x into dx. 2x into dx will be equal to dt. Yeah. Now you are integrating the function with respect to t. So what is the integration of sine t? It is equal to minus cos t plus, you have to write the constant. So finally you have to write the value of t. So this is equal to minus cos of value of t is x square plus 1. So x square plus 1 plus c. So this is the integral of a given function. So clear? First give the substitution, then differentiate, then you have to substitute the values. Finally you need to integrate the function. Now let us see this one. See here, two methods are possible. You can give the substitution as first root x. Okay. If you give the substitution as root x, then again you have to give the substitution. I mean 2 times you have to do. Okay. Instead of that, here see, can I give the substitution as tan root x or secant root x? If I give the substitution as secant root x, okay. If I give the substitution as secant root x, then what is the derivative of a secant function? It will be equal to secant x is equal to secant x into tan. So we will not get this. Right? But if I give the substitution as tan root x, what will be the derivative of tan root x? Secant square root x, right? So that I will get the secant square root x. Is it clear? In that way you have to see. For what? We have to give the substitution. Is it clear? If you give the substitution for secant root x, you will not get that the value. But if you give the substitution for tan root x, derivative of tan function will be equal to secant square x. So you will get this one. Clear? So what you have to do the substitution? Tan root x. Let, you need to practice these problems. Okay, let t is equal to tan root x. After the substitution, you have to differentiate. Now we'll differentiate the function with respect to t. Derivative of t will be equal to 1. Derivative of tan root x will be equal to secant square root x. Not only this much. Here next you have to differentiate the function root x. That's why I told you differentiation should be good. So this is root x. Derivative of root x will be equal to 1 divided by 2 root x but you are differentiating with respect to t. So derivative of x with respect to t will be dx by dt. Clear? So here this is the integration. Okay. This substitution we have given. So we need secant square root x divided by root x into dx. So for that we have to do the substitution. So what we can write this as secant square root x divided by, right, secant square root x divided by root x into dx is equal to 2 into dt by rearranging. So clear? Secant square root x divided by root x into dx will be equal to 2 into dt because we need a substitution of that. So now I will substitute here. See, we need the integration of tan to the power 4 root x into secant square root x divided by root x into dx. So this is equal to integration of tan to the power 4 root x. What is tan root x? T. So this will be equal to t to the power 4. Now secant square root x divided by root x into dx. This value, right? Secant square root x dx divided by root x I can write as 2 into dt. I hope you are getting this. So this, now you can integrate this, right? 2 is a constant as it is. Integration of t to the power 4. You have to increase one part. So this will be equal to t to the power 4 plus 1 will be equal to 5 divided by 5. Right? So this is it, plus, see, after the integration only you have to write the plus c, constant. Okay? So plus c. So again I can write this as 2 by 5. The value of t. What is t here? Tan root x. So I have write tan to the power 5 root x plus c. So this is the integral of a given function. See here, this one directly we cannot integrate, right? So that we have to use the substitution method. You can go with any method, substitution or partial fraction or by using the parts. Depend on the problem. You have to see which method you have to use. Okay? Look at this problem. I hope you can see which substitution we have to give. Whether tan inverse x or 1 plus x square. Which substitution we have to give? If you give substitution for 1 plus x square, derivative of this will be 1 will be 0, x square will be 2x, but it is not there. So this substitution is not possible, right? But if you give the substitution for tan inverse x, what is the derivative of tan inverse x? Obviously it is equal to 1 by 1 plus x square, right? So that will get this value. Is it clear? So directly what we can give the substitution as tan inverse x is equal to t. Okay, let us start. Let tan inverse x is equal to t. Now differentiate with respect to t, so that derivative of tan inverse x is 1 divided by 1 plus x square, and you are differentiating with respect to t. So derivative of x with respect to t will be equal to dx by dt is equal to 1. Actually no need to write this step, directly you can write 1 by 1 plus x square, x will be dx, t will be equal to dt. Okay, I will substitute this. I is equal to c, integration of, I will write again, sine of tan inverse x divided by 1 plus x square into dx. Here you can see this, 1 by 1 plus x square into dx will be equal to dt. That is 1 by 1 plus x square into dx is equal to dt. So we will substitute that. So this is equal to integration of sine, and we have given the substitution as tan inverse x as t, right? Sine, is it clear? Tan inverse x is t, then dx by 1 plus x square will be equal to d. Now it is in the simplest form, right? We can find the derivative, integral of this function. Integration of sin t will be equal to minus cos t plus c, right? So this is equal to, finally substitute the value. This is important, okay? Minus cos of value of t is equal to tan inverse x. Minus cos of tan inverse x plus c. So this is the integral of a given function. This is all about the integration by substitution method. We know the right? Integration of a sin x is no. Integration of cos x is also no. But what about the integration of tan x, integration of secant x, cot x and cosecant x? So now by using a substitution method, we are finding the integrals of these four functions. Okay, by using substitution method, we have to find the integrals of these functions, and then later onwards we will consider this as a one formula, and these formulas will be added to your main list. Okay, first we will find the integral of tan x. See, integral of tan x, you should remember this, and this method is also important. You can expect 2 mark question from this. Okay, integral of tan x, remember tan will be equal to c log of mod secant x plus c. Remember, I hope you remember all the formulas, so add this formula. Integration of tan x into dx is equal to log mod of secant x plus c. Now we will prove this one. See, integration of, I will consider tan x into dx. So this is equal to integration of tan x can be written as sin x, right? Sin by cos, integration of sin x by cos x into dx. Now here we have to see the substitution. See, if I give the substitution as sin x, for example, if I give substitution as sin x is equal to t, okay. Now derivative of sin x will be equal to cos x into dx will be equal to dt will give. But here we don't have cos x into dx, right? So this substitution is not possible. Is it clear? If you give the substitution as sin x, we will not get this because 1 by cos x is there. So this substitution is not possible. So we have to choose the substitution as cos x function. Is it clear? Let I give the substitution t is equal to cos x. Now differentiate with respect to x. Okay. Now derivative of t with respect to, you have to differentiate with respect to t. Derivative of t with respect to t will be equal to 1. Derivative of cos x will be equal to minus sin x into derivative of x with respect to t will be equal to dx by dt. By this what we can write, sin x into dx is equal to minus dt. Right? Now we will substitute. So integral of sin x, I hope you are getting this, sin x by cos x into dx will be equal to integral of sin x into dx, sin x into this one, right? Sin x into dx will be equal to minus dt into 1 divided by cos x. We had given the substitution as cos x is equal to cos x is equal to t. So this is equal to 1 by t. So by using this what we can write, minus integration of 1 by t will be equal to your log of mod t. I hope you remember the formula, log of mod t plus c, right? So this is equal to minus log of, what is the value of t? T is equal to cos x. So minus log of cos x plus c. Again, see here we don't want this negative sign. We will remove this negative sign. How? This is equal to minus, directly we can write, okay, no need to write these things, log of mod cos can be written as 1 by secant, right? So this is equal to 1 by secant x plus c. So again this one I can write as minus log of secant inverse, right? Secant inverse x plus c. Log m to the power n will be equal to n log m. Log m to the power n will be equal to n log m. So here minus will come here. So this is equal to plus log mod secant x plus c. So this is a form. Okay. Remember, integration of tan x is equal to log mod of secant x plus c. Remember this formula. Similarly, we will find the integration of these three forms. Integration of cot x into dx. Remember this formula. Integration of cot x into dx will be equal to log of mod sin x plus c. Remember, tan log of mod secant x plus c. Integration of cot x will be equal to log mod of sin x plus c. Similar to that, simple it is cot x is equal to integration of, right, cot can be written as cos by sin cos x divided by sin x into dx, right. Here we need to give the substitution for sin function, right. So we will substitute that. Let sin x is equal, there we have given the substitution for cos. Here denominator we have to keep, okay. Let sin x is equal to t, differentiate with respect to t, derivative of sin x will be cos x, directly I'll write, into dx is equal to t. Is it clear? So sin x will be cos x, then dx by dt is equal to 1. So what we can write? Cos x into dx is equal to dt. Let us substitute that. Integration of cot x into dx is equal to integration of cos x divided by sin x into dx. So this can be written as integration of cos x into dx will be equal to dt divided by sin x, substitution is t, okay. So this is equal to integration will be log of mod t plus c. Anyway negative sign is not there, so directly we can write log of mod t value is sin x, log mod of sin x plus c. Okay, remember integration of tan x and integration of cot x. Next one, integration of secant x into dx. This is also log mod of secant is there, so tan and secant log of tan x plus secant x plus c. Okay, integration of secant x will be equal to log mod of tan x plus secant x plus c. You need to remember this. We'll prove this also. See, integration of secant x into dx, directly we cannot do this one. For that, what you have to do is, here in this formula only, tan x plus secant x is there, right? So we need to multiply and divide it by tan x plus c. Sorry, tan x plus secant x. Is it clear? In the formula, if they ask to prove this one, then what you can do? Integration of secant x into dx. In the formula it will be given tan x plus secant x. So you need to multiply and divide it by that value. So if I multiply and divide it by same, so see here secant x multiply and divided by same tan x plus secant x divided by tan x plus secant x into dx. Is it clear? We have multiplied and divided by the same function here, tan x plus secant. Now give the substitution for this one. Tan x plus secant x, let tan x plus secant x is equal to t. Now differentiate with respect to t. Okay, derivative of tan x. What is the derivative of tan x? Secant square x, right? So this is now secant square x plus derivative of secant x will be secant x into tan x. So you have to remember each and everything into dx is equal to dt. So here you can see this one, secant x is common, right? We'll take out secant x into what is remaining here, secant x plus here secant x is out, so remaining with tan x into dx is equal to dt. And we'll substitute here. Okay, I'll take this as 1, not write again. 1 implies integration of here secant x into tan x plus secant x. Secant x into secant x plus tan x into dx is equal to dt. So we'll substitute dt divided by tan x plus secant x. We had given the substitution as t. If you integrate this, 1 by t will be equal to log mod t plus c. So this is equal to log mod t is tan x plus secant x plus c. So this is the third one. Okay. So we'll recall once, integration of tan x will be equal to log mod of secant x plus c, integration of secant x into dx will be equal to log mod of sin x plus c, and integration of secant x into dx will be equal to log mod of tan x plus secant x into plus c. Okay, remember these three. Now last one more is remaining. We'll see that formula. Integration of cosecant x into dx is equal to, remember, log of mod cosecant x minus cot x plus c. Okay, integration of cosecant x dx is equal to log mod of cosecant x minus cot x plus c. Let us start with this. Integration of cosecant x into dx. In your textbook, different method is given. I feel this whatever the method I use now, this is easy. You can go with any method. So what I do is I multiply and divide by the same function. Okay, similar to the previous one. So cosecant x multiply and divide by the cosecant x minus cot x divided by, okay, cosecant x minus cot x into dx. Now this substitution we have to give cosecant x minus cot x. So we will give that. Put cosecant x minus cot x is equal to t. Now differentiate with respect to t. Okay, and derivative of cosecant x is minus cosecant x into cot x, and derivative of cot x is minus cosecant square x. So minus into minus will be plus cosecant square x into dx is equal to dt. Here cosecant x is common, we will take out. If I take cosecant x common, remaining with minus cot x plus cosecant x into dx is equal to dt. So we can give the substitution. So this substitution I take this as 1. So 1 implies integration of cosecant x into cosecant x minus cot x into dx will be equal to dt divided by cosecant x minus cot x, substitution is t. So this is equal to t. So this is equal to log of mod t plus c. So this is equal to now log of, what is mod t? The value of t is cosecant x minus cot x. This I can write cosecant x minus cot x plus c. Okay, this is the integration of a cosecant x function. Add all the 4 formulas to your formulas list. Okay, remember these formulas.